So chapter 18.2 is going over rational exponents. So it's playing off of the notes from 18.1 where we found that, okay, the nth root, so for example, the square root can cancel if something is being squared because they're the same number. In these notes, these are just going to show you another way how to write the nth root. So we're going to go over the definition of a to 1 over n and the definition of a to the power of m over n. We're going to learn to convert between the rational exponents and radical notation, the properties of rational exponents, and then a few applications. So the first concept here is the definition of a to the power of 1 over n and a to the power of m over n. So the definition of a to the power of 1 over n, all it's saying is that we can take the nth root and we can write that nth root as a power. So instead of seeing, for example, the cube root of a, we could write this as a to the power of 1/3. So whatever number is here on the nth root is going to be the number that is here on the denominator of our power. Okay, so in these first examples, all of our fractions here that are powers are going to be with a numerator of 1. So the only number we're changing is that denominator. So looking at this example, it says convert the expression to radical form and simplify as possible. Okay, so we're taking this number that's raised to a power and we're going to turn it into radical form. So we said that 1/3 power is the same as writing what? Cube root of -8. Okay, so we took that 1/3 and converted it to cube root. Okay. And then in the previous notes, we learned how to solve this. So since the cube root is odd, will this have an answer or will it be no solution? It will have an answer. So if our nth root is odd, which is 3 is odd, that means we can take the square root of a negative number. So we would do the prime factor tree off of 8. 2 goes into 8 4 times. 2 goes into 4 2 times. We're going to be circling a pair of 3. So 3 of them is going to be in our pair. And we have one pair, meaning our answer is going to be what? 2. But since our nth root was odd and our number is negative, it's not just going to be 2, it's going to be -2. So that's our answer for A. We converted it and then we solved. So for part B, we have 81 to the 1/4 power. How can we convert that to a radical? Good, it's going to be the 4th root of 81. 4th root of 81. So what do we do next to solve this? Good, you could type it into your calculator or we can do the prime factor tree. So from 81, we know 3 goes into 81 27 times. 3 goes into 27 9 times. And 3 goes into 9 3 times. So knowing that we're going to have to group this in 4s, what's our answer? 3, because this is our group. We only had one group of 3, so we pull out that answer, which is 3. What about C? Is that power of 1/2 attached to the 100, or is it attached to the negative 100?
100.
Just the 100. How do we know?
No parentheses.
There's no parentheses. So that means we're just going to convert this part here, and the negative is going to go where?
Outside.
On the outside. So how can we write 100 to the 1/2 power?
Negative square root of 100.
Good. This would be negative square root of 100. And what's the square root of 100? So that means we have negative 10. So the only reason we have that negative is because it was not attached to the power, the exponent, so we had to move it out to the front. Okay, so what's different between C and D?
The negative's on the inside.
Good, the negative is on the inside. So how would we convert this to a radical?
To the square root of -1.
It's good, so it'd be the square root of negative 100. Because that 2 signifies square root, and for square root, we don't have to write the 2 here. Okay. But since that 2 is even, can we have the square root of a negative number? No, so that means our answer is what?
No solution.
No solution. It's very important we understand the difference between part C and part D. One with the parentheses, one without the parentheses.
So on D, the reason you put the 2 in on top of the square root is just because there's already a 2 there, right?
Yeah, there's already a 2. Just like on C, I could have just wrote a 2 here. But on the square root, they usually don't write that 2 because it's assumed. But for the purpose of notes, yes, there is a 2 there. Okay. What about E? What's different about E than the rest of them?
Fraction got a negative.
Good, our fraction has a negative. So if you remember anything about the properties of exponents, how do we get rid of a negative power? A negative exponent.
Flip it.
Close. So we're not flipping anything, but we are going to do something where we have to move this whole thing somewhere else.
You'll be fine.
So not quite. So let me write this rule over here. So this is a property of exponents. To get rid of a negative, we have to move the entire problem to the denominator. Denominator. Okay. So right now, if we were to look at this problem, since it's a whole number of 16, our denominator right now is just 1. It's a whole number. So in order to get rid of that negative in the exponents, we're going to have to move this entire thing to the bottom. Meaning, now what is on the top? 1. So now we have 1 over 16 to the 1/2 power. When we move it to the denominator, our exponent goes from negative to positive. Okay? The opposite is true. If our question started off in the denominator and it had a negative exponent, we could do the opposite and move this to the numerator. Okay, so wherever it is originally, you just move it to the opposite part, and that gets rid of the negative exponent. So now that we no longer have a negative exponent, how can we rewrite this as a radical?
1 over the square root of 16.
Good, 1 over the square root of 16. And if we were to simplify that, we would get what answer?
1 over 4.
1 over 4. So our answer is 1/4. Again, we have to do this to get rid of negative exponents. Okay, any questions on the first part? Okay, now we're going to look at the definition of a to the power of m over n. So now in this case, instead of having a 1 in our numerator for our power, it could be a different number. So we could rewrite this a to the m over n, as a to the 1 over n raised to the power of m. Or another way to look at this is that this number, let me get this. This number is our nth root. This number is our exponent that we're going to have outside of the whole problem. So exponent outside. So that means if we had a to the power of 3 over 4, which number is our nth root, the 3 or the 4? So look right here. The 4, that bottom number. So the 4th is our nth root, so we would write 4 root a. And that top number 3 is telling us that we are going to cube that entire problem. So that means that the 4 went attached to the radical and the 3 went on the outside of the problem. So we're going to use that knowledge to convert each expression to radical form. Okay. Any questions before we look at the examples? Okay, so in the first one we have 8 to the power of 2/3. Which one is our nth root? 3. It's always the bottom one, so we have the cube root of 8. And what are we going to do with that 2? It's going to square the whole problem on the outside. Okay, so what we did is we converted it. Now we're going to have to solve. Okay, so I do the prime factor tree on 8. Okay, since this is the cube root, how many of the 2's am I going to be circling? 3 of them. Meaning my answer to this cube root of 8 is going to be what? 2. But I have to write this as 2 and then square it. Because all I did was just answer this first part here. That's where the 2 came from. So then once I square it, I get my final answer of 4. So for these ones, there's just one extra step. So once we find the answer, we do whatever it's telling us to do. In this case, it told us to square it. So for part B, how would I write that? What's my nth root? 2. So that means I have 2 outside the radical, which is the same as saying the square root. What number goes inside? And then what happens with that 5 on the top?
Square it. There.
Well, the whole thing gets raised to the power of 5. Okay, so first just doing this inside part here. What's the square root of 100? 10. And then what are we going to do with that 10? To the 5th power. So 10 to the 5th power is the same as writing that 10 with 5 zeros. So 1, 2, 3, 4, 5. So that means our answer is 100,000. Does everyone see where the nth root is going and where the exponent is going? What do we see different about part C? It's a fraction. So just like how we gave the radical to the numerator and the denominator of the fraction, we could rewrite this the same way. So technically this is 1 to the power of 3/2 over 25 to the power of 3/2. Okay? Just like when I had the radicals and I could separate it from numerator and denominator, I could do the same thing with those powers. So now converting each one, that numerator is going to have what number as the nth root? 2. So I have the square root of 1, and then that whole thing is being raised to the power of 3. What about the bottom? Good, I'm going to have the square root of 25 because of that 2 for the nth root, and then the whole thing is being raised to the power of 3. So simplifying this, what's the square root of 1? 1, and then I'm cubing that. What's the square root of 25? 5, and then I'm cubing that. What's 1 cube? Remember, this is the same as saying 1 times 1 times 1. 1, and then what's 5 cubed? 5 times 5 times 5. 125. So that means our answer is 1 in 125, or 125ths. 1 over 125.
Could we just write the square root of 1 over 25 in just one single parentheses to the 3rd power? Or would that just...
Yeah, you could. Yeah, you could. The only reason I suggest doing this way is it breaks it up each step, so you're less likely to make a mistake. Okay. Part D, what do we notice about our exponent? It's negative. How do we get rid of a negative exponent? Move the whole problem to the denominator. So this whole thing is going to be moving down. So that means I have 1 over 4 to the positive 3/2. I got rid of that negative power. How am I going to write 4 to the 3/2 as a radical? Yes, the square root of 4, because of that 2. That 2 is our radical, our nth root. All of that cubed because of that 3. Notice how I'm only doing this to the denominator because that's the only part being affected. So that means I have 1 over, what's the square root of 4? 2, and then what's 2 cubed? 8, because remember that's 2 times 2 times 2, so the answer is 1/8. Or again, you could be typing this into your calculator. If you type in this, exactly how it looks, with the parentheses, square root of 4, close parentheses, power of 3, you will get 8. Okay. Okay, last one for this concept. So now that negative 81 is going to be under our radical. Okay. What is our nth root here? 4. So this is going to be the 4th root of negative 81. And then what? All of this raised to what power? 3. But since our nth root is even, can we have a negative under the radical? No. So that means the answer to this is no solution. And again, this is because this is even. Okay. If it was odd, would we be able to continue and get an answer?
Yes.
Yeah. Next concept here is converting between rational exponents and radical notation. So we're doing the same thing, but now we have variables. That's the only thing that's different. Same thing, but now we have variables. So that means it's not always going to be able to simplify, because we can't always simplify if we just have a variable there. Okay. So how could we rewrite a to the power of 3/5? Good. The 5th root of a, because whatever's on the denominator goes to the root, and then the whole thing cubed. Can we simplify that? No, because we don't know what a is. Okay, so this is our answer. And the next one, however, we have a number and a variable. Okay, so we're going to do each one separately. So for the first part, 5 to the 1/3 power, how can I rewrite that? Good, cube root of 5. Do I need to do anything with that 1? No, because technically what that 1 is telling me is to raise everything to the first power. And does that change the problem? No, that's like multiplying by 1. Okay. How would I rewrite the x? Good, the cube root of x squared. Okay. So if we could choose to leave it like this, however, since both parts have the cube root, we can combine it into one radical. So this would be the cube root of 5x squared. The reason for that is that we can take this part, and since it's saying the cube root of x squared, that's the same as saying the cube root of x times the cube root of x. That's where that x squared came from, because that is the same as putting this all together, the cube root of 5xx, which again is the same as that x squared. Again, we were able to combine this into one because they both had the cube root. If one of them was like the 4th root, we couldn't combine them because it's 2 different roots. Okay. Now let's look at part C. So what's getting affected by that 1/4? The y or the 3y? So why is it just the y and not the 3y?
It's not parentheses around 2 of them.
Good. So the only reason it would contain the 3y is if there was parentheses like this. But since there's not, that means we are only looking at that power being raised to y. Okay. So So that means in our answer, we're going to have a 3 in the front because there's nothing, the 3 is not being affected by anything. How would I write y to the 1/4? Good, the 4th root of y. So that 3 remains on the outside, and I have the 4th root of y. This is my answer. Because I can't simplify anything further because we don't know what y is. And same with part D. What is that negative 3/4 attached to? The z. Okay. So that means we need to get rid of that negative power by doing what? And move it to the bottom. Are we moving the 9 to the bottom? No, just this part where it has the z. What if the 9z was in parentheses? Would we move the whole thing then? Yes. Okay. So that means we now have 9 over z to the positive 3/4. Okay. How would we write z to the 3/4? Good, 4th root of z, and then all of this cubed. Okay, 4th root of z cubed, yep. And then that's our answer because we can't simplify any further. The only other thing we could, I guess, simplify a little further is that this part here is the same as doing the 4th root of z 3 times. And if we were to combine that all into one radical, it would be the 4th root of z cubed. Okay. Either would be correct. You'd get points for either. Because the main thing here was converting from a exponent to a radical. Okay. Any questions on that concept? Okay. For these examples, it says convert each expression to an equivalent expression by using rational exponents. Assume all variables are positive real numbers. So we're doing the opposite here. Okay? Now it gives us the radical and it wants us to put this into an exponent. So all we need to remember here is that the number that's being cubed, so the number that's an exponent is which part of our fraction, the top or the bottom? Top. And the other part is going to be top or bottom. Okay, so that means this is the same as writing b to the power of 3/4. And that's our answer. Okay. What about part B? We don't see an exponent attached to that 7a, so we assume it's 1, because we're looking just right here. We're looking this part. We don't see an exponent, so we assume this is 1. We don't see a nth root, so we assume that's 2. Since the 7a is both together under the square root, that means our 7a is going to be in parentheses. And what's going to be the power? 1/2. That's the answer. So again, we're just converting the opposite now.
Wait, how did you know 7a was going in parentheses?
Because they're both under the radical sign. So unlike B, we notice that C has a number outside of the radical sign. So what are we going to do with that 7?
Put it on the front by itself.
Good, put it in the front by itself. Okay, we just move the 7 into our answer. That means the only thing we're looking at here is this square root of A. So how could we write that with a power? 1/2. Remember, A squared is not the same as the square root of A. Square root of A is the same as A to the power of 1/2. So A to the 1/2. And then that would be our answer. The relation between A squared and the square root of A is that they cancel each other out. They're opposites. Okay, so we got 7A to the 1/2 power. Okay, one last concept here. And that is the properties of rational exponents. So this is talking about the properties of exponents. So you don't need to write everything here. What you need to know is for the first part, if you're multiplying like bases. So what that means is that your number that has the exponent is the same. So in this case, they're both A. So multiplying like bases, you add the exponents. Okay. If you're dividing like bases, so they're both A, then you subtract the exponents. This goes on to the properties of exponents. Okay, the power rule, we talked about the power rule, that says if we have a base being raised to a power and then being raised to a power again, we multiply those powers together. We also talked about the power of a product. So if we have two things being multiplied and they're in parentheses, we said that that exponent goes to both. It goes to everything inside that parentheses. Same with power of a quotient. If we had a fraction raised to an exponent, that's the same as giving that exponent to the numerator and the denominator. Okay. If you need further definition on that, then I would look at these examples later. Okay. Those are just examples describing these rules. Okay. We also talked about negative exponents. So if we had a negative exponent, in order to make it positive, we have to place that part in the denominator and then make the exponent positive. Okay, so we did examples like that. And then the last rule that we haven't seen yet is the zero exponent. And all that says is anything raised to the 0 power is 1. So 5 to the 0 power, 1. 10 to the 0 power, 1. Anything raised to that 0 power. This would be something, again, good to have on hand for the next exam. Even better would to have them memorized. Again, this is all being recorded, so you can watch this again later. Okay, so we're going to use the properties and simplify these problems. So here we have same bases of y that are being multiplied. So what are we going to do to the exponents? Add them. So this is the same as saying y to the power of 2/5 plus 3/5, which equals y to the 5/5, which is the same as saying what? Y to the first, which we can write as y. So the answer is y. So for multiplying the same base, we add the exponents. Okay. On part B, before we can do anything, we're going to have to do what to that a to the negative 1/2? Yep, we have to move that to the bottom. Are we moving the 6?
No.
Nope, just the a. So that means we have 6 over a to the 1/2 times a to the 3/2. We have the same bases of a that are being multiplied, so what do we do to the exponents? Add. So we have 6 over a to the 1/2 plus 3/2. Okay. What's 1/2 plus 3/2? 4/2. And can 4/2 simplify? To just 2. So this is 6 over a squared. Okay, so those we're both talking about, those properties of negative exponents, and then multiplying means we add the exponents. What about on part C? Which one is this describing?
None of them are like bases, so you wouldn't add anything.
That's correct. None of them are like bases because we have an S, a T, and a W, so we wouldn't be adding any exponents. But what could we do to this 4?
Oh, you could distribute that.
You could distribute, and when you distribute this 4, what are you doing with the 4 and the exponent? Multiplying. So this is the same as saying S to the 1/2 times 4, T to the 1/3 times 4, and W to the 3/4 times 4. So simplifying this, 1/2 times 4 is what? 2. So this is S squared. What's 1/3 times 4? 4 over 3, so T to the 4 over 3. And what's 3/4 times 4? Good, which is 3. So this is our simplified answer. Okay, any questions on that concept? We have one more problem left. So again, this is using the properties of exponents. Last one is applications involving rational exponents. So it's just one last problem. So this says, suppose P dollars in principal, that's supposed to say principal, is invested in an account that earns interest annually. If after T years the investment grows to $8, then the annual rate of return R on the investment is given by this formula. So this formula is R is equal to A divided by P raised to the 1 over T power minus 1. Find the annual rate of return on 5,000, which grew to $6,894.21 after 6 years. So it gives us our formula that R is equal to A over P raised to 1 over T minus 1. And then it gives us information here. All this information. We have to figure out what each of this part is labeled as. Okay? So looking at 6 years, 6 years tells us it's what variable? T. T. So this is T. What about that 5,000? So it started at 5,000 and then grew to that 6,000. So what would be 5,000 and what would be the new value?
R would be the 6,000.
R would be the 6,000. Remember, R is our annual rate of return. And that's what we're trying to find. So we're trying to find R. So for sure we're going to have R in our problem. 5,000 is P, because P is our starting value. Notice that A says investment grows to $8. And it says that it grew to 6,000 something. So this is our A. So now that we have everything labeled, we're going to plug everything in. So we have R is equal to A, which is 6,894.21, divided by P, which is 5,000, raised to the power of 1 over T, so 1 over 6 minus 1. Okay, so in order to simplify this, I would first type this part into your calculator. Okay. Once you type that part into your calculator, then take that number and raise it to 1/6. And then subtract 1. So this is the answer that you should get if you type this whole thing into your calculator, 0.055. Did everyone get the same? Okay. However, that 0.055 is not our answer because it wants a rate. And a rate is usually in what? A percent. So how are we going to turn 0.055 into a percent?
Decimal.
Move the decimal how many places and where?
2 spaces right.
2 to the right. So we would move this 2 to the right, meaning that our answer is going to be what percentage? 5.5%. So our sentence would be what?
The annual rate of return would be 5.5%.
Good. The annual rate of return is 5.5%. And that's the answer.